Hi, everyone. This is section 13.3. Ran out of time because of the shortened periods today. With the quarter ending next week, we have to get these notes in, so I apologize. I don't like to use notes on video, but we are going to do these, and I want you to take notes. I'm going to try to go as slow as I can. So everyone watch this video, please. Today is Friday, October 5th. Fill in these notes. Okay. If you were absent today, I'll make sure that I send a blank copy of these home so you can do this. So a vertical asymptote is found by setting the denominator equal to 0 and solving for the x values. Holes in the graph occur whenever there is a common factor in the numerator and denominator. An x value cannot be both a hole and an asymptote. They both are discontinuities, but they're not both. So this is just kind of a review of what we just did in the last section. So we have x plus 3, x plus 2, and x minus 1. That means, and then we also have a removable one. Okay, so let's remove this first. So the first one is a hole. So the hole is at -2 something. And we're going to remove it. Remove it from the problem. So now we're left with f of x equals x plus 3, x minus 1. That's what we're left with. If you want to know what the hole is, you need to plug -2 in wherever you see an x over here. So it'd be -2 over -2 plus 3, -2 minus 1, which is -2 over 1 times -3, which is -2/3, which is positive 2/3. So the hole is at -2 and 2/3, which is about right there. Now, that's just the hole. So let's get that out of here. The rest of this we're going to graph by finding first vertical asymptotes. Your vertical asymptotes, you look at the denominator and set those both equal to 0. So one of them is x equals -3 and one of them is x equals 1. I'm looking at the denominator when I say that. So we're going to come over to our graph and we're going to draw these in. We got -3 and we have a 1. So that means there will be 3 pieces of a curve. Okay. Now, well, let's go ahead and find the horizontal asymptote first, then I'll tell you. The horizontal asymptote, because the beginning degree is 1x and this says 2x's, this is smaller in degree than this. A linear is smaller than a quadratic. Therefore, it's y equals 0 for your horizontal asymptote. So we're going to draw that in. Sometimes in a 3-part graph, one piece of this curve you can actually go through the horizontal asymptote in one section. So 2 sections will stay true to the horizontal asymptote, but one section could cross. I know it's weird, but because of it being 3 sections. Okay, so x-intercepts. How do we find x-intercepts? We set the numerator equal to 0. The numerator is just x. So if you set that equal to 0, it is 0. So that means it's going to cross at 0, 0. So I know it's not supposed to because it's a horizontal asymptote, but the horizontal asymptote will be true in this section and this section over here. Y-intercept is if you let x equal 0, what would that be? If you let x equal 0, it's 0 over anything is 0. So it's also y equals 0. So there it is. X and y-intercept are both 0. All right, now if you wanted to plug some points in, stuff like that, you can, but I'm going to actually let you guys punch this one in your calculator. So I know that most of you have a fraction key. So if you have a fraction key, use it. If not, since I'm going to do this for the people that don't have a fraction key, because you have 2 factors in the top, I'm not going to graph it with all of these. I removed the whole. I already found the whole stuff. So I'm just going to do what's left. So I'm going to do parentheses x. Actually, I don't know that I need parentheses. Let me clear that out. Let's just do x divided by. And I need double parentheses here because I need one parenthesis for both factors. And then I need separate parentheses for the individual factors. So I'm going to do 1, 2 left parentheses. This is for those people that have to type this in this way. X plus 3, parenthesis, parenthesis again for the second factor, which is x minus 1. Whoops, do that again. X minus 1, parenthesis, parentheses. Do you see how I had to group those? One set of parentheses was not enough for this. You need two. You need to group both factors in there. Oh my God, you can't see that because of the glare. See how I have two left parentheses? Two left parentheses to start. Two right parentheses to end. Anyway, let's press zoom 6 and see what it looks like. Just for fun, watch this. What if gosh, can you even do this on this graph? How do you graph? Okay, never mind. I'm not going to do that for fun. Get what I'm saying? All right, so this is what our curve's going to end up. So I'm going to go to my t-table, okay? Let's go to our t-table. I'm going to find, oh, this is not good. Go by ones. I went to second window, started at 0, went by ones, and then pressed second graph to look at my t-table. All right, do you see the error? There's an error at 1. I'm going to get some numbers around the error signs. So the first error was at -3 because that's the vertical asymptote. So give me some points to the left of this error. So I like, is there any nice numbers? There's a nice number at -915, but it doesn't look like I can graph that. So I'm going to go with, let's just pick one that I can graph. Here's -6. Okay, so -6 is about -0.28. So -6 and -2, so that's on the bottom side of the asymptote. I need one more. So I'm going to get right next to the asymptote, -4, -0.8. -4, -0.8 is right there. This one's going to hold true to the horizontal and vertical asymptotes. And there's your first curve. Now I need the numbers in the middle. Now I've already got 2 points on the middle curve. I kind of need one over here. Maybe let's look at -1. Let's look at -1 here. -1.25. And you kind of know what it looks like. So let me see how. Just keep in mind that it's going from vertical asymptote to the next vertical asymptote. So I'm just going to come alongside this vertical asymptote, jump over the hole, hit this point, and then come down to this vertical asymptote. And now this last one. Again, we want to go to the right of the vertical asymptote. So go find the next asymptote, which is at 1. And give me some points to the right of that vertical asymptote, 1 error. See where it says 1 error? That's the second asymptote. So how about we graph 2 and 0.4? Let's look at 4. Let's graph 6. 6 is 0.133. So that's like right here. And then we're just going to follow the asymptotes and keep above the horizontal asymptote there for the third curve. Okay, so there's the graph. Now, number 2 says, describe the left-sided and right-sided behavior of the graph of f of x around its vertical asymptotes. So we're going to only talk about vertical asymptotes when we describe left-sided and right-sided behavior. So starting with this first vertical asymptote, this one right here. So what you're going to say is, as this graph approaches this vertical asymptote from the left, what is this curve doing? It's going down. So we're actually describing this one. As your x's come towards the vertical asymptote from the left, the y of that end behavior is going down. So you would say, as x approaches the vertical asymptote, which by the way is x equals -3. So as x approaches the vertical asymptote -3 from the left, so you go like this. As x approaches from the left, approaches -3. Some people put it here and some people put it over here, but I'm going to put it by the x. From the left, as x comes from the left, and it's going towards the vertical asymptote, the y is approaching -infinity. Now, we're going to talk about the x coming from the right. So here's the x's again. So here's the curve. As this is coming towards the vertical asymptote from the right, as this curve approaches the vertical asymptote -3 from the right, what is it doing? So you're describing this end. Describing this end right here. So as the curve approaches the vertical asymptote -3, what is the curve end doing? It's going up. So you would say as x from the right of the vertical asymptote -3, the y approaches positive infinity. Some people put the negatives here and positives here, or some people put it like this. As x approaches the vertical asymptote from the left, as x approaches the vertical asymptote from the right, or some people put the negative and positive here. I'm okay either place. So that's the first vertical asymptote. Now we're describe the second vertical asymptote. So the second vertical asymptote was x equals 1. So you would say as x from the left approaches the 1, and as x from the right approaches 1. Or you can put the -1 up here. Or sorry, not the -1, the negative and the positive. From the left of 1, from the right of 1. What is the y doing? So you just can kind of get that set up. So here's the 1. You see it? So the curve. Here's the curve. Put your pencil somewhere on the curve. You don't even have to worry about this curve because this curve isn't even approaching the 1. This middle one is approaching the 1 from the left. This third curve over here is the one approaching the 1 from the right. So we're talking about the second and third curve here. So as this curve approaches 1 from the left, what is its end behavior doing? And we're talking about this end behavior. It's going down. Now, from the right, okay, here's your vertical asymptote. Focus on your vertical asymptote. From the right, when the x's were positive and they're getting smaller towards the 1, what is this end behavior doing? It's going up. And that's how you talk about end behavior around the asymptotes. Because the asymptotes are called infinite discontinuity, and they like to see what the curve is doing around the asymptotes, around those discontinuities. All right, so the whole part of this section is called rational inequalities. That first one wasn't even a rational inequality. It was just teaching you about end behaviors. Now this is the start of the actual section right here. So I don't like when my inequalities are on this side of my rational expression. So the first thing I would do in this problem is I would rewrite this like this. Now, we're going to do a number line. And this whole thing is a rational function. It's a curve on the graph. And it's going to be centered around a vertical asymptote of 4. So there's basically we got to subtract 12. I'm so sorry. We have to subtract 12 from this problem. All right, the first thing we're going to do is we're going to find the vertical asymptote. And when we find it, we're going to place a hole, an open circle, on the number line. So we're going to take n minus 4 and we're going to set it equal to 0 and solve. N equals 4. So we're going to come over here, write 4 somewhere. I'm not sure where exactly I want this, but I'm going to put an open circle there. That's a discontinuity in the graph. It will never be 4, because if it was 4, this denominator would be 0. The second thing I want you to do is I want you to do the same exact problem, but I want you to set it equal to 12, and I want you to find n. In other words, whatever n is that equals 12 is called a 0 of the function. So solve for n. So we're going to cross multiply. Like this. Okay, and then you're going to subtract 9 over, get 3n. We're going to add 48 over. You're going to get 99, and n is 33. So at 33, let's make it up. It's like right there. 33, you're going to put an open circle because the original inequality does not have an equal sign. It's a greater than sign. Since there's no equal sign, it's an open circle. If that would have been greater than or equal, you would have had a closed circle. So we're going to have an open circle at 33. So basically we have 3 sections of the graph. We have the numbers 3, 2, 1, 0, all the negatives. We have 5, 6, 7, all the numbers up to 33. Then we have the numbers after 33, like 34 and 35. So there's 3 sections of the graph. You're going to pick which sections work. I'm not going to make you do sections in each one of these. I want you to pick one number and every other section works. So we're going to choose 0. And we're going to plug 0 into the original problem. So we are testing. I'm going to do it up here. Test 0. So if I test 0 in this, it'd be 12 is less than 0 plus 51 over 0 minus 4. Is 12 less than negative 51 fourths? Is a positive number ever less than a negative number? The answer to that is no. That means this section does not work. Oh my gosh. This section does not work because that's where the 0 was. That means this section does work. And that means the section does not work. So your answer would be 4 to 33. Any number from 4 to 33, not including 4 and 33, would be able to be plugged in here. And this side, anything between 4 and 33 would make this number greater than 12. Now, what does that look like in a graph? Now, if I was putting this in a graphing calculator, I want to compare it to 0. I don't like the 12. I hate the 12. So what I would do is up here, I would write 9n plus 51, and then I would subtract 12, like this. Okay, I would subtract 12. So I'm going to use the fraction key this time because it's going to be easier. And if you don't have a fraction key, then you're going to have to put some parentheses around here, subtract 12. Like you might have to put parentheses on the whole thing, then subtract 12. But this one's going to be easier with the fraction key, so I'm doing it. I'm going to go alpha y and bring up my n over d. And I'm typing this in as a fraction. So we have 9n, or 9x, plus 51. And then we're going to go n minus 4, or x minus 4 on the bottom. Get out of the fraction, and then put minus 12. And we're going to compare this to, because you subtracted 12 over there, we want to know when this all is greater than 0. We want to know when it's greater than 0. But first, we're going to have to set our window. It's already telling me my x's are 4 to 33. So at least if you go to window, I want my x's to go from at least up to like 40. Actually, let's just go to 50. The y's don't have to be that great. I don't care about the y's that much. I care about the x's. Okay, so I'm going from negative 10 to 50 on my window. The y's are negative 10 to 10. And let's graph. I need to see some more x's, looks like. Let's go to window. Let's go negative 50. What the heck? Let's just go negative 50 to 50. We wanted to know when this was greater than 0. Okay, we got to remember there's a vertical asymptote in here as well. The vertical asymptote was 4. And because these are going by 50, the 4 is way over here. The 4 is like way over here close to the x-axis. So when is this greater? So it's greater right here. Just in this portion right here of the curve. That's the only part it's greater. So basically, we just have to know what that number is. You know what that number is? It's 33. This number is 33. I don't have to look at anything to know that that's 33. Now, if I wanted to look at my t-table, second window, I could start at 33. And I will show you that at 33, you have a 0. You guys see? At 33, there's a 0. We already found that when we solved for this problem, right there. We solved and got n is 33. So I knew at 33 I know that that's 33. I don't really have to look at my t-table to know that I already solved it. And then there's an asymptote at 4. So basically, it's greater than 0 from 4, the asymptote, to 33. That's the only time it's greater. You'll notice that after 33, it's less than 0. And before the 4, this whole thing is always less than 0. This part right here will never, ever cross the x-axis. And that's because there was a asymptote somewhere around right here. Looks like an asymptote. It's this curve will never even get, this curve will never, ever get greater than the x-axis. So the only portion greater than that is right there. So you could probably figure this out by a graphing calculator without doing any work. but I just showed you the words. All right, I talked too much. So now we're doing this next problem on the back. So this next problem is less than or equal to 0. I know it doesn't say that, but I want you to make it less than or equal to 0. So now we want to know when this rational function is less than or equal to 0. It's always easier when it starts with a 0. That last one had a 12, so it made it a little bit more awkward. So what we're going to do is we're going to get a number line ready. We're not graphing this, but we will look at this on the calculator. So what you have to do basically is find and follow these steps. We're going to set equal to 0, which it is equal to 0. We're going to plot these points on the number line, zeros and vertical asymptotes. What I do is I like to do the vertical asymptote 0 first. So we're going to set the denominator equal to 0 and x is 4. This is a discontinuity. Basically, if x was 4, this problem would be undefined because you're not allowed to divide by 0. So what you're going to do on the number line is you're going to go up here and put a 4, and you're going to put an open circle. Open circle on all discontinuities. If you graph this, I'm going to show you on the graph real quick. X squared minus 2x minus 15 divided by x minus 4. You will know if I looked at the t-table. Second window, wait a minute, I'm going to start this. Second window, start your t-table back at 0. You will see there's an error at 4. You guys see it? Error at 4. That's a vertical asymptote. Open circle, meaning it's an error. Okay, I'm going to write error. It can never be that. It's a vertical asymptote. It's not a 0 of the function. It's a discontinuity of the function. Second step. Now, your numerator, I want you to factor it. Think of your numerator in factored form and set them equal to 0. Because these are the same thing as your x-intercepts. Your x-intercepts and zeros are the same thing. So one of your zeros is 5 and one of them is negative 3. This is where the curve will cross the x-axis. So at 5, I need you to put a closed circle, and at negative 3, 3, 2, 1, 0, 1, 2, 3, we're going to put another, this is negative 3, another closed circle. The reason these are closed circles is because the original inequality was less than or equal. That means if it was 5, it would be equal to 0. If it was 5, if x was 5 and you plugged it in, this whole thing would be equal to 0 because 5 makes this top 0. And if you plug the negative 3 into this top, it's going to make the top 0 and it'll make it equal to 0. So that's why these are closed. So now we have 4 sections. We need a number from one of these sections. Zeros, like here's 3, 2, 1. Zeros right here. So we have this section over here to the left. We have a section in between negative 3 and 4. We have a section between 4 and 5. And we have a section over here. We're going to test in 0. So test 0 to the original problem. So we're going to have 0 squared minus 2 times 0 minus 15 over 0 minus 4. 0, 0, 0. So you're going to have 15 fourths. Is 15 fourths less than or equal to 0? No. So that means this section does not work. That means this section does. So from negative infinity to negative 3, bracket. That works. Okay, that works. And then this section from 4 to 5 works. And this section does not work. So this section does. This section does. And these two sections do not. This is when it's less than 0. This is the only time that the graph will fall below 0. We're going to look at that. Let's press zoom 6. When does our graph fall below 0? Oh, goodness. Keep in mind there's a vertical asymptote right here. Okay? That vertical asymptote, remember, was 4. Okay? So when is it below 0? It looks like it's from negative infinity up to this number. What do you think that number is? It's negative 3, right? It's below 0 from negative infinity to negative 3. And then it's above 0. Then there's an asymptote. So from the asymptote to this next 0, from asymptote 4 to 5, here's asymptote. From 4 to 5, it's below 0 again. So it's below 0 from 4 to 5 right here. I don't know if you understand the graph, but you could also look at the t-table to look at that. So let's look at the t-table. I want you to go start at like -5, and I want you to go by tenths. Basically, it's when are the y-coordinates negative? When are the y-coordinates negative? Right now, all the y-coordinates are negative. When do the y-coordinates become 0? What number do you think it is going to be? I say -3 because that's a 0, right? At -3, you should see a 0. So it's from -3, from -infinity to -3, it's below 0. That's why this answer says -infinity to -3. So it's negative, 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 up to -3. Then it's going to be positive. Positive. So none of these work because we wanted to know when it was less than or equal to 0. So none of these are your answer. So between -3 and the error sign, which by the way is at 4, it's going to be positive. These are all positive. Look at that. Those are all positive numbers. You could do this forever. My vertical asymptote's really far away. It's 4. I'm just going to keep pressing this down. See how they're all positive? All those y's are greater than 0. We're looking for the ones that are negative, the ones that are less than 0. So when we get to the 4, you're going to see an error sign, and I want you to stop the graph. Stop. Okay. Up to 4, it was always positive. So anything from -3 to 4 was all positive. None of those worked. But when you get to this error, notice the y's became negative. See the negatives? Those are part of your solution. Those work. Those work. That works. They're all less than 0. All the y's are less than 0. But then it became a 5, and then it became 0. Okay, and that's why there was a 5 in our answer right here. From 4 to 5, they were all negative. But when it hit 5, they started going positive again. That's why anything greater than 5 did not work. So I hope that makes sense to you. Let's try another one. All right, ready? Number line. First thing, vertical asymptotes. The vertical asymptote is x squared minus 9, which if you factor it, is -3 and 3. These are called discontinuities. Discontinuities are open circles. So at -3, -2, -1, 0, 1, 2, 3, and 3, open circles. Those are holes in the graph. Okay, those are asymptotes on the graph. Right here and here. They're asymptotes. They're asymptotes. Okay? We're looking for when the graph is greater than 0. We want anything that's above the x-axis here. Second thing, take your numerator and set it equal to 0. X equals 1. This is called a 0 or an x-intercept of the problem. Find 1. There's 2, 1. Here's 1. And we have to either put an open or closed circle. It's also open because the original inequality is a less than. The original inequality is not an equal. So it's also open. So we have 3 open circles. We have 4 sections, sorry. So we're going to test one section. Test one section. Let's test the section that has the 0, which is right here. The 0 is right here. So we're testing this one. That's the one we're testing. We're testing this section because it has a 0. So if you test the 0 into the problem, you end up with 1/9. Is 1/9 greater than 0? Yes, it is. So we want this section to work. So one of my answers is -3 to 1. They're both parentheses. They're both parentheses because they're both open circles. That means the section to the left of this does not work. The section between 1 and 3 does not work. And then it also works over here. So anything from union with 3 to infinity will also work. 3 to infinity. This is your answer. So I've already graphed this. Or did I graph this one? Heck, I don't think I did. Okay, I did not graph this one. So go to your alpha, y equals 1. Type in x minus 1. And then type in x squared minus 9. In graph. We wanted to know when it's greater than 0. That means above the x-axis. So it's not over here. This is not this is not above the x-axis. Now this part is see how that's above? This is above the x-axis. So when is that? It's from asymptote, -3, to the next asymptote. Actually, it's not the x-axis. It's to 1. Sorry. It's to 1. Let's look at that. Should I look at Zoom 4? See, it was above 0 from the asymptote -3 until it hit the 1. And then it went below. Do you see that? So from the asymptote to 1, it was above. That's why it says -3 to 1. And then it was below for a while. And then it came back above after the second asymptote at 3. This was an asymptote. It was above from asymptote to infinity. This never ever, if you look at the window, like if you would increase the x-axis to like say 100, x max, increase to 100, watch this graph. This second curve, this third curve right here will never ever go below the x-axis. So it's going to be greater forever. It doesn't look like it. It looks like it's on the y, this x-axis, but it's above the whole time. So if you look at the t-table, second graph, look after the 3. See, after the 3, it should all be positive. So you could go down forever. Looking at the y-axis, it's positive forever. And if you want to go second window and go like to 100, just to see what it is, it looks like zeros, but they're still positive numbers. They're close to 0, but they're still positive. They're never, ever going to be negative. Anyway, that's it.